June 6, 1944, 0630 hours, 5 miles off Normandy. Coxswain Ray Nance gripped the wheel of his LCVP as it plunged through 6-foot swells toward Omaha Beach. Behind him, 31 soldiers from the 116th Infantry Regiment huddled in the crowded well of the landing craft, soaked by spray and sick from the violent motion. The flat-bottomed boat slammed into each wave, transmitting brutal shocks through the hull. Nance had trained for months on this exact craft, learning to read the surf, to time his approach to the beach, to drop the ramp at precisely the right moment. The LCVP landing craft, vehicle, personnel, though everyone called it the Higgins boat after its designer, was deceptively simple. A shallow draft plywood boat with a protected bow ramp, powered by a diesel engine, operated by a crew of 3. Nothing about it seemed revolutionary. Yet without this boat and the thousands like it approaching Normandy's beaches that morning, D-Day would have been impossible. The LCVP and its larger cousin, the LS landing ship, tank represented solutions to a problem that had stymied military planners for decades. How to deliver armies directly onto hostile beaches without requiring captured ports. The story of how engineers reinvented the landing craft is the story of how amphibious warfare was transformed from a tactical operation into a strategic capability that changed the course of World War II. Amphibious warfare landing military forces from ships onto hostile shores has challenged commanders since ancient times. The problems are fundamental. Ships require deep water, but soldiers need to reach land. Troops and boats are vulnerable and can't fight effectively. Heavy equipment can't swim. Throughout history, amphibious assaults either required capturing ports where ships could unload normally, or accepting severe limitations on what forces could land and how quickly. The Gallipoli campaign of 1915 demonstrated both the potential and the problems of amphibious assault with industrial-age militaries. British and Anzac forces attempted to land on Turkish beaches and seize the Gallipoli Peninsula. The landings were chaotic disasters. Soldiers rowed to shore in open boats, were shot climbing out over the sides, and struggled to get equipment ashore. The campaign failed partly because the landing forces couldn't get ashore quickly enough with adequate equipment to overcome Turkish defenses. The interwar period saw limited progress. The U.S. Marine Corps developed amphibious warfare doctrine through the 1920s and 1930s, recognizing that future Pacific wars would require seizing defended islands. But the equipment available, standard Navy ships' boats, was inadequate. Troops had to climb down cargo nets from transports into small boats that then rowed or motored to shore. Getting heavy equipment like artillery and vehicles ashore required either captured ports or elaborate, time-consuming improvisation. The fundamental problem was the interface between ships and shore. Ships have deep drafts, they sit low in the water and need deep channels. Beaches' shallow, gradually water depths decrease as you approach shore. Traditional boats needed enough water depth to float, but couldn't go shallow enough to let troops out on dry land. Soldiers had to wade through surf, often in water over their heads, while carrying heavy equipment. Many drowned. Those who reached shore were exhausted and disorganized. The British developed landing craft in the 1930s for potential amphibious operations, but these were specialized vessels produced in small numbers. The motor landing craft, MLC, could carry vehicles but required a crane to unload them. The landing craft mechanized, LCM, had a bow ramp but was slow and had limited capacity. These craft proved concepts but weren't suitable for large-scale operations. When Germany conquered France in 1940, Britain faced the possibility of having to invade occupied Europe. Any invasion would require landing huge forces on defended beaches, something that had never been accomplished at that scale. The equipment available, standard ships, boats, and small numbers of specialized landing craft was completely inadequate for the scope of operation that would be required. The problem wasn't just landing initial assault forces. An invasion would require sustaining armies ashore with continuous flow of reinforcements, ammunition, fuel, vehicles, and supplies. This meant not just getting soldiers onto beaches, but establishing logistics pipelines that could deliver thousands of tons of material daily. Traditional naval operations depended on ports for this logistics. Amphibious operations would need to create artificial ports or develop craft that could deliver supplies directly to beaches. Andrew Jackson, Higgins owned a small boatyard in New Orleans that built shallow draft boats for oil exploration and trapping in Louisiana bayous. His boats had a unique design. Instead of pointed bows that cut through water, they had spoonbill bows, flat surfaces that planed over shallow water. The design allowed boats to operate in water just inches deep, then reverse off without getting stuck. The Marine Corps, searching for landing craft designs in the late 1930s, tested Higgins boats and found they worked well in surf conditions. But they had a critical limitation. Troops had to climb over the sides to disembark, making them vulnerable to enemy fire and slowing the landing process. The Marines needed a boat that could deliver troops directly onto the beach through a protected ramp. Higgins was shown Japanese landing craft designs captured during the 1937 conflict in China. The Japanese boats had bow ramps that dropped down, allowing rapid disembarkation. Higgins immediately saw how to incorporate this feature into his design. Within months, he had built prototypes combining his shallow draft hull with a protected bow ramp. The resulting LCVP landing craft vehicle personnel was brilliantly simple. The boat was 36 feet long with a beam of 10 feet 10 inches. The flat bottom allowed it to run right up onto beaches in as little as 3 feet of water. The sides were plywood over a wooden frame, providing protection from small arms fire while keeping weight down. The bow ramp was steel, hinged at the bottom, lowered by a simple cable and pulley system. The propulsion was a 225 horsepower, gray marine diesel engine driving a tunnel-mounted propeller protected by a metal shroud. This protected propulsion system was crucial. It prevented the propeller from being damaged by obstacles and allowed the craft to reverse off beaches without fouling. The engine was positioned amidships, where its weight helped balance the heavily loaded boat. The crew consisted of a coxswain who steered and controlled the engine, and 2 crewmen who handled lines, operated the ramp, and managed passengers. The simplicity meant that crews could be trained quickly. Unlike specialized landing craft that required Navy training, LCVPs could be operated by personnel with just weeks of instruction. The passenger capacity was initially rated at 36 troops, or a jeep with crew. In practice, the boats often carried more, cramming troops into the well deck shoulder to shoulder. The troops stood for the approach to the beach. There were no seats holding onto rails and each other while the boat crashed through waves. Comfort was sacrificed for capacity and simplicity. The LCVP's performance capabilities matched its mission requirements. It could make 9 knots fully loaded, fast enough to reach beaches quickly but slow enough that the coxswain had control. The range was approximately 50 miles, adequate for operations from transports positioned offshore. The shallow draft, just 3 feet aft, 2 feet forward, allowed it to reach beaches where deeper draft craft would ground out too far from shore. The construction was deliberately simple to enable mass production. The boat used standard plywood, readily available lumber, and off-the-shelf mechanical components. No specialized shipyard facilities were required. Higgins eventually built a production empire in New Orleans that employed over 20,000 workers, but he also licensed the design to other builders. LCVPs were built in yards across the United States, from Louisiana to California to the Great Lakes. The genius of the design was how it solved multiple problems simultaneously. The flat bottom allowed shallow draft operation, but also made the boat stable enough to drive directly onto beaches. The bow ramp provided protected disembarkation, but also allowed reverse. Loading vehicles could drive in forward and drive out forward. The plywood construction was light enough for good performance, but sturdy enough for rough use. Every design element served multiple purposes. Higgins was a difficult personality, argumentative, profane, and convinced of his own brilliance. But he could deliver results. When the military needed design changes, Higgins would implement them immediately, sometimes having modified prototypes ready within days. His ability to iterate rapidly and his willingness to adopt good ideas regardless of their source made him the ideal partner for developing landing craft under wartime pressure. The LCVP wasn't perfect. The ride was brutal in rough seas. The flat bottom made it pound through waves, battering passengers and making seasickness universal. There was no protection from the elements. Troops got soaked by spray during the approach. The plywood construction was easily damaged by obstacles on beaches or by enemy fire. But the boats worked, could be produced in massive numbers, and solved the fundamental problem of getting troops onto beaches. While the LCVP solved the problem of landing infantry, it couldn't deliver the tanks, artillery, and heavy vehicles armies needed. Initial attempts to land tanks used standard transports and cranes, which were far too slow and vulnerable. The solution required a different approach: a ship that could beach itself and unload vehicles directly onto shore. The landing ship Tank LS-2 was designed in late 1941 through collaboration between British and American naval architects. The concept was audacious: create a seagoing ship that could cross oceans, then deliberately run aground on beaches to unload cargo. No one had attempted such a design at that scale before. Ships that could cross oceans had deep drafts and couldn't approach shores. Shallow draft vessels couldn't handle open ocean conditions. The design that emerged was a compromise that somehow worked. The LST was 328 feet long with a beam of 50 feet. The hull had a distinctive shape, relatively deep forward for ocean seakeeping, but flattened aft with a shallow draft of only 4 feet when unloaded. The ship could displace up to 4,000 tons loaded but still beach in 3 to 4 feet of water. The key innovation was the ballast system. The LST had ballast tanks that could be flooded with water to increase draft for ocean crossings, providing stability and seakeeping. Approaching a beach, the ballast tanks were pumped out, reducing draft and allowing the ship to run up onto the beach. The process took about 2 hours but allowed the ship to transition from ocean vessel to beached cargo platform. The bow doors opened to reveal a ramp that lowered onto the beach. Vehicles could drive directly from the tank deck through the bow onto the shore. The tank deck was 240 feet long and 30 feet wide, able to accommodate 20 Sherman tanks or 60 trucks or equivalent mixed cargo. A second deck above carried additional vehicles or supplies. The propulsion system used twin diesel engines developing 1,800 horsepower total. This wasn't much power for a ship this size, resulting in maximum speeds around 10 to 12 knots. The LST was slow, and sailors joked that LST stood for Large Slow Target, but the mission didn't require speed, it required the ability to deliver cargo directly to beaches, and that the LST could do. The crew complement was approximately 110 officers and men, plus capacity for several hundred troops. The LST wasn't designed for comfort. Accommodations were cramped and basic. But the ship could cross oceans, land on beaches, unload cargo, retract, and repeat the process indefinitely. No previous naval vessel had been capable of this operational cycle. The production of LSTs required manufacturing innovation. Traditional shipyards built ships in permanent slipways, limiting production rates. LST production used modular construction. Major sections were prefabricated inland, transported to shipyards, and welded together. This allowed production rates that would have been impossible with traditional methods. American shipyards eventually built over 1,000 LSTs during World War II. The construction time dropped from several months per ship to as little as 2 months as production was refined. The scale of production transformed amphibious capability, where previously landing tanks required elaborate preparations and specialized equipment. Now entire fleets of LSTs could deliver armor directly to beaches anywhere in the world. The British also received LSTs under Lend-Lease, using them extensively in Mediterranean operations before D-Day. The Soviet Navy received several LSTs which they used in Black Sea operations. The LST became a universal platform employed by all Allied navies, proof of how effectively it solved the vehicle landing problem. The LST's versatility exceeded its original mission. LSTs served as repair ships, hospital ships, aircraft ferries, and general cargo transports. They operated in the Arctic, the Mediterranean, the Pacific, and the Indian Ocean. Some were converted to LST hospital ships, with medical facilities installed on the tank deck. Others became rocket launching platforms, mounting dozens of rocket launchers for beach bombardment. D-Day required more landing craft than any previous operation by orders of magnitude. The invasion plan called for landing 5 divisions, approximately 156,000 men on the first day, plus thousands of vehicles and tons of supplies. The logistics of delivering this force to the beaches required an armada of landing craft larger than most national navies. The invasion employed approximately 4,000 landing ships and craft of all types. The LCVPs numbered in the thousands. Exact counts vary by source, but certainly over 1,500 Higgins boats participated. LSTs numbered over 230. Larger LC is landing craft infantry, carried troops. LCTs, landing craft tank, carried vehicles. LCMs, landing craft, mechanized, provided medium-capacity vehicle transport. Each type served specific roles in the choreographed landing sequence. The organization required to manage this fleet was unprecedented. The landing craft were organized into flotillas and squadrons, each with specific beaches and timing. The schedule specified when each wave would land, what equipment they would carry, and where they would beach. The complexity rivaled modern air traffic control, except these were boats in rough seas rather than aircraft in controlled airspace. The crews operating the landing craft were mostly young sailors with minimal experience. Many were teenagers who had never been to sea before joining the Navy. Their training focused on basic seamanship and the specific procedures for their craft type. Coxswains learned to read surf conditions, time their approach to beaches, and drop ramps at the optimal moment. The training was compressed but apparently adequate. Most landing craft successfully delivered their loads despite crew inexperience. The loading process at British ports began days before the invasion. Troops, vehicles, and supplies were loaded onto LSTs and transport ships in carefully calculated sequences. The vehicles had to be loaded in reverse order of how they would be needed ashore: last in, first out. Ammunition, fuel, and medical supplies were distributed across multiple ships to prevent single losses from creating critical shortages. The waterproofing of vehicles was elaborate and essential. Every opening that water could enter, engine intakes, exhaust pipes, door seams had to be sealed. Engines were treated with waterproofing compounds. Electrical systems were protected with grease and tape. The waterproofing allowed vehicles to wade through several feet of water, but it wasn't perfect. Many vehicles drowned out when seals failed or water depths exceeded design limits. The Channel crossing began the night of June 5th. The invasion fleet assembled from ports across southern England, Portland, Portsmouth, Southampton, and others, forming up into lanes marked by buoys and patrol craft. The organization required to get thousands of vessels moving in the correct sequences without collisions was extraordinary. Some landing craft were towing barrage balloons for anti-aircraft defense. Others carried specialized equipment like bridge-laying tanks or flamethrower tanks. All had to proceed at speeds the slowest could maintain, making the crossing take most of the night. The sea state was rougher than desired. Winds of 15 to 20 knots created 4 to 6 foot waves. For the small landing craft, especially the LCVPs, this made for brutal crossings. The flat-bottomed boats pounded through waves, throwing spray over everyone aboard. Seasickness was universal. Troops spent the crossing vomiting, soaked and increasingly miserable. Some landing craft swamped and sank during the crossing, their crews rescued by escort vessels. The landing sequence began with specialized armor-DD duplex drive swimming tanks, dozers to clear beach obstacles, and engineer vehicles. These launched from LCTs several thousand yards offshore and made their way to the beaches. Behind them came the first waves of infantry and LCVPs, time to arrive just after the specialized armor. Following waves brought more infantry, weapons, and supplies in precisely timed intervals. Omaha Beach, where American forces faced the most intense resistance, became a killing ground partly because landing craft couldn't adjust to the unexpected opposition. The plan called for specific landing sequences and intervals. When early waves were pinned down on the beach and suffered heavy casualties, follow-on waves landed into the same killing zones because the schedule didn't allow for adaptation. Landing craft coxswains approaching the beach could see the carnage, but had orders to land at specific points at specific times. Utah Beach, where resistance was lighter, showed how well the landing craft worked when opposition was less intense. The landing craft delivered successive waves with machine-like precision. Vehicles drove off LSTs directly onto the beach. LCVPs shuttled between transports and shore, bringing troops and supplies continuously. The beach organization worked largely as planned because German resistance didn't disrupt the landing sequence. The British and Canadian beaches Gold, Juno, and Sword fell between these extremes. Resistance varied from sector to sector. Some landing craft took heavy fire and suffered casualties. Others landed without opposition. The variability meant that some areas developed bottlenecks when damaged landing craft blocked beach exits, while others processed traffic smoothly. The flexibility of having thousands of landing craft meant that problems in one sector could be partially compensated by redirecting craft to less congested beaches. The landing craft that participated in D-Day weren't identical to those that had been designed years earlier. Continuous refinement based on combat experience had produced numerous improvements and specialized variants. The LCVP had been modified based on lessons from North Africa, Sicily, and Italy. Armor protection was increased on the sides and ramp. The ramp mechanism was strengthened after early versions sometimes jammed under load. Radio equipment was improved to allow better communication with beachmasters coordinating landing schedules. The changes were incremental but collectively improved reliability and survivability. The specialized landing craft variants reflected creative solutions to unexpected problems. The LC-TAR landing craft, tank, rocket, mounted racks of rockets that could saturate beach defenses immediately before landings. The LCVPR carried similar rocket systems scaled to the smaller boat. These fire support variants provided suppression that helped initial waves reach beaches, though their effectiveness varied depending on accuracy and enemy defensive arrangements. The LCG landing craft, gun-mounted destroyer-grade guns on landing craft hulls, creating mobile fire support platforms that could get close to beaches and engage specific targets. The guns gave landing forces responsive fire support during the vulnerable period when they were on beaches, but artillery hadn't been landed yet. The LCGs operated close to shore despite their vulnerability, providing fires that made crucial differences in several sectors. The specialized engineer landing craft carried equipment for clearing beach obstacles. Some had cranes for lifting obstacles, others had explosive charges for demolition. The engineer craft were priority targets for German defenders because clearing obstacles was essential to allow follow-on waves to land safely. The crews of these craft suffered disproportionate casualties but accomplished missions essential to the invasion's success. The LCM, though less famous than the LCVP and LST, provided critical medium-capacity vehicle transport. LCMs could carry a tank or several trucks, bridging the gap between the small capacity of LCVPs and the large capacity of LSTs. The flexibility LCMs provided allowed more efficient matching of cargo to transport capacity. Rather than using LSTs for small loads, LCMs could handle medium-sized cargoes efficiently. The DUKW, the Duck, was an amphibious truck that could operate both as boat and as wheeled vehicle. DUKWS would drive off LSTs into the water, motor to shore, then drive up beaches and inland to deliver cargo. The DUKW solved the problem of transferring supplies from landing craft to shore transportation. Instead of unloading onto beaches and reloading onto trucks, the DUKW combined both functions. The versatility made DUKWS enormously popular despite mechanical unreliability. The Rhino ferries were improvised heavy cargo platforms built in England specifically for the invasion. They consisted of pontoon sections assembled into large rafts that could be towed by LCVPs or small tugboats. LSTs would drop ramps onto Rhino ferries in deep water, vehicles would drive onto the ferries, and the ferries would be towed to shore. This allowed LSTs to unload without beaching, keeping them mobile and reducing beach congestion. The Mulberry harbors represented the ultimate solution to the port problem. These were complete artificial harbors built in England, towed across the channel in sections, and assembled off the invasion beaches. The Mulberries allowed cargo ships to unload directly into lighters that then carried cargo ashore, dramatically increasing logistics capacity. While technically not landing craft, the Mulberries were part of the same solution space, bringing cargo to beaches rather than requiring captured ports. The landing craft developed for European operations proved even more valuable in the Pacific, where the island-hopping campaign required amphibious assault after amphibious assault. The lessons learned at Tarawa, Saipan, Iwo Jima, and Okinawa refined amphibious doctrine and landing craft employment. Tarawa in November 1943 revealed deadly problems with landing craft assumptions. The LV-2 landing vehicle, Tract, was an amphibious tractor that could crawl over coral reefs that stopped conventional landing craft. At Tarawa, the tide was lower than predicted, and many LCVPs and LCMs grounded on reefs hundreds of yards from shore. Marines had to wade through waist-deep water under withering fire. Casualties were appalling. The lesson was that landing craft had to be able to cross reefs, or operations had to use amphibious vehicles that could. The LVT became essential to Pacific operations after Tarawa. The LVT could swim from ship to shore, climb over reefs, then crawl up beaches using its tracks. Various models carried troops, cargo, or weapons. The LVT mounted a tank turret, providing armored fire support. The LVTs weren't fast or comfortable, but they could reach beaches that defeated conventional landing craft. Saipan in June 1944 showed improved landing craft coordination. The Marines employed LVTs for the initial waves, getting troops over reefs and onto beaches. Once beaches were secured, LCMs and LSTs brought in heavy equipment. The lesson from Tarawa had been learned. The combination of LVTs for initial assault and conventional landing craft for logistics worked effectively. Iwo Jima in February 1945 saw perhaps the most intensive landing craft operations of the Pacific War. The volcanic ash beaches and steep beach gradient created challenges conventional landing craft weren't designed for. LSTs struggled to beach effectively because the steep gradient meant they grounded in deeper water than expected. LCVPs and LCMs had to shuttle vehicles from LSTs to shore, slowing logistics. Despite these challenges, the landing craft delivered 2 Marine divisions to the beach and sustained them through a month of brutal combat. Okinawa in April 1945 represented the culmination of Pacific amphibious operations. The landing was unopposed initially, allowing landing craft to function perfectly in conditions they were designed for. The lessons of years of island warfare had been incorporated into procedures. The landing craft delivered 4 divisions to beaches on L-Day with minimal confusion or loss. The efficiency demonstrated how far American amphibious capability had advanced since the early war. The kamikazes threatened landing craft as they had threatened other naval vessels. Radar picket LCSS landing craft, support armed with anti-aircraft weapons provided defense against air attack. Despite these measures, kamikazes sank or damaged dozens of landing craft throughout the Okinawa campaign. The vulnerability of thin-skinned landing craft to air attack was accepted because their mission was essential despite the risks. The scale of landing craft production during World War II represented one of the great industrial achievements of the war. Building over 23,000 landing craft of all types required mobilization of manufacturing capability that extended far beyond traditional shipyards. Higgins Industries in New Orleans became the largest private employer in Louisiana, with over 20,000 workers at peak employment. The company operated multiple plants producing LCVPs, LCMs, PT boats, and other vessels. Production at peak reached several boats per day from each plant. The workforce included large numbers of women, African Americans, and other groups historically excluded from skilled industrial work. Higgins was colorblind in his hiring. He needed skilled workers regardless of their background. The working conditions were demanding. The plants operated multiple shifts, running 24 hours a day. Workers handled heavy materials in humid Louisiana heat. The work was physically demanding, requiring strength and stamina. Accidents were common despite safety procedures. Yet morale remained high because workers understood the importance of their output. They knew landing craft they built would carry soldiers into combat, making quality a patriotic duty. The material requirements were enormous. Plywood production had to be increased to supply landing craft construction. The glues used in marine plywood required specific chemicals that competed with other war needs. Steel for ramps, engines, and fittings consumed thousands of tons monthly. Lumber, paint, hardware, and countless other materials all had to flow continuously to keep production lines running. The quality control challenges were significant. Landing craft had to be built quickly, but also had to function reliably in combat. Defects could mean drowned troops or failed missions. Inspectors checked welds, tested engines, verified that ramps operated smoothly. The testing was less rigorous than peacetime standards but caught major defects. Each craft completed a brief trial run before being accepted. The transportation of completed landing craft was itself a logistics challenge. LCVPs could be shipped on freighters or loaded onto LSTs for transport overseas. LSTs sailed from construction yards to overseas theaters under their own power, though the slow speeds meant transoceanic crossings took weeks. Some landing craft were shipped partially assembled and completed overseas, saving transportation space but requiring assembly facilities in forward areas. The financial investment was substantial. Each LCVP cost approximately $8,000 and $1,944. LSTs cost about $1.5 million each. The total program cost exceeded $1 billion, equivalent to perhaps $15 billion in modern currency. The investment represented recognition that amphibious capability was strategic necessity that justified enormous expenditure. The civilian boatyards that never built military vessels before the war learned to produce landing craft. Yards that had built fishing boats or recreational vessels converted to military production. The conversion required new tools, new skills, and new procedures. The government provided technical assistance, training, and financial support. The distributed production meant that even if major manufacturers like Higgins had production disrupted, overall capacity would remain adequate. Behind the statistics and technical descriptions were the men who operated the landing craft under fire. Their experiences, preserved in memoirs, oral histories, and official reports, reveal what it was like to crew these vessels in combat. The coxswains who steered LCVPs to the beach faced unique psychological pressures. They could see the beach they were approaching, could see German defenses firing, could see troops from earlier waves pinned down or casualties in the surf. Yet they had orders to approach specific beach sectors at specific times. The temptation to veer away from the most dangerous areas must have been intense, but most coxswains held their course and delivered their troops where ordered. Reinvented, approaching Omaha Beach on D-Day, later described the approach as surreal. The bombardment from ships created smoke and dust that obscured the beach. Shells passed overhead with sounds like freight trains. Explosions threw up geysers of water. Despite this chaos, he had to navigate to his assigned beach sector, time his approach to arrive with his wave, and drop his ramp at precisely the right distance from shore. The concentration required to do the job while fear screamed to take evasive action was extraordinary. The troops aboard the LCVPs had perhaps worse experiences than the crews. Crowded into the well deck, unable to see what was ahead, sick from the violent motion, they could only wait. The sound of bullets hitting the ramp told them they were under fire before they could see anything. When the ramp dropped, they had to run forward into whatever awaited, having no choice but to trust the coxswain had positioned them correctly. The LST crews developed different relationships with their ships than sailors on conventional vessels. LSTs were slow, uncomfortable, and deliberately run aground everything traditional sailors were trained to avoid. Yet LST crews took pride in their ships. They could deliver cargo directly to beaches, something no other vessel could do. The mission justified the discomfort and the risks. Some LST crews participated in dozens of landings throughout the war, from North Africa through Sicily and Italy to Normandy and then to southern France and finally to Pacific operations. These veteran crews developed expertise in beaching procedures, cargo operations, and damage control. Their experience was valuable enough that some crews stayed with the same ship throughout multiple theaters. The casualties among landing craft crews are difficult to quantify, precisely because they're often included in overall naval casualties rather than broken out separately. But landing craft operating close to shore under direct fire suffered significant losses. At Omaha Beach alone, dozens of landing craft were destroyed or damaged. Crews were killed by artillery, mortar, and small arms fire. Some landing craft sank after hitting underwater obstacles, drowning crew and passengers. The decorations awarded to landing craft crews included several medals of honor, numerous Navy crosses, and thousands of lesser medals. The recognition acknowledged that operating landing craft in combat required courage equivalent to any combat role. The crews went into danger repeatedly, knowing that each approach to a hostile beach might be their last. The landing craft that delivered D-Day to the beaches enabled strategic effects that extended far beyond the immediate tactical operation. The ability to conduct large-scale amphibious operations fundamentally changed Allied strategic options and forced German defenders to disperse forces protecting thousands of miles of coastline. The uncertainty about where invasions might occur forced Germany to defend everywhere. The Atlantic Wall required hundreds of thousands of troops and enormous quantities of concrete, steel, and other materials. These resources defended against invasions that came at places and times of Allied choosing. The landing craft capability gave Allies initiative, forcing Germans into reactive defensive postures. The flexibility of amphibious operations allowed Allied forces to bypass strong points and attack where defenses were weaker. The island-hopping campaign in the Pacific exemplified this operational approach. Rather than attacking every Japanese-held island, American forces could land where they chose, isolating Japanese garrisons that couldn't be reinforced or resupplied. The strategic mobility that landing craft provided was more valuable than any specific tactical capability. The logistic sustainability of beached LSTs meant that invasions could be sustained even without captured ports. The Mulberry harbors off Normandy supplemented but didn't replace the cargo. flow through LSTs and other landing craft beaching directly. When storms destroyed one mulberry and damaged the other, the invasion logistics continued through beach operations. The landing craft had eliminated ports as invasion prerequisites. The post-war strategic environment was fundamentally shaped by amphibious capability. The United States and Soviet Union emerged as superpowers partly because they possessed capability to project power across oceans and onto hostile shores. Britain maintained amphibious capability despite economic constraints because it recognized the strategic value. The landing craft developed for World War II influenced post-war naval development and doctrine. The World War II landing craft remained in service for decades. LSTs participated in the Korean War, Vietnam War, and various smaller operations. Some remained active into the 1990s, over 50 years after their construction. The longevity reflected both the basic soundness of the designs and the continuing need for amphibious capability. The Higgins LCVP evolved into post-war landing craft but maintained the same basic concept. The LCVP was eventually replaced by the LCM-6 and later designs, but the fundamental approach bow ramp boat that beaches itself remained standard. Modern landing craft are larger, faster, and more sophisticated, but they operate on principles Higgins established in 1941. The LST design influenced commercial ship development. Roll-on, roll-off, RoRo. Cargo ships that allow vehicles to drive directly on and off employ concepts pioneered by LSTs. Car ferries use bow and stern ramps derived from LST technology. The commercial shipping industry benefits from innovations developed for military landing craft. The amphibious warfare doctrine developed during World War II remains foundational to modern operations. The U.S. Marine Corps maintains amphibious capability as its core mission. The coordination between landing craft, support vessels, air cover, and shore parties established during World War II continues to guide current doctrine. The lessons learned landing on hostile beaches under fire remain relevant to military planners. Andrew Higgins never received the public recognition his contributions deserved during his lifetime. He was difficult personality, made enemies, and struggled with financial problems after the war. He died in 1952, relatively unknown outside naval circles. Only later was his contribution to victory fully recognized. Eisenhower reportedly said the war was won by Lincoln's letter to Mrs. Bixby, the atomic bomb, and the Higgins boat. The quote is probably apocryphal, but it captures the landing craft's importance. The Higgins boats and LSTs that survive today, preserved in museums or private collections, represent tangible links to D-Day and the amphibious campaigns that won World War II. Visitors can walk through LSTs and sit in restored LCVPs, experiencing the cramped spaces and simple construction that somehow changed history. The story of how engineers reinvented the landing craft is ultimately a story about solving impossible problems through pragmatic design and industrial determination. The landing craft that delivered D-Day to the beaches weren't elegant or sophisticated. They were simple boats built from plywood and steel, operated by barely trained crews, that accomplished what military theorists had considered impossible. The Higgins boat succeeded because it solved the fundamental problem of getting troops from deep water to dry land quickly and in large numbers. The bow ramp, the shallow draft, the protected propulsion, each feature addressed specific aspects of the problem. The simplicity allowed mass production. The ruggedness allowed operation by inexperienced crews under terrible conditions. The design wasn't optimized for any single characteristic, but balanced multiple requirements adequately. The LST succeeded because it eliminated the artificial distinction between ships and landing craft. By creating a ship that could cross oceans and beach itself, the LST solved the strategic logistics problem that had limited amphibious operations throughout history. The ballast system that allowed the LST to transition from deep draft ship to shallow draft landing craft was conceptually simple but operationally revolutionary. The industrial achievement of producing over 23,000 landing craft during the war years represented American manufacturing capability at its peak. The distributed production, the rapid training of workers, the compression of development timelines all reflected industrial mobilization that exceeded what Germany or Japan could match. The landing craft weren't just weapons. They were products of an industrial system that could outproduce any adversary. The human courage of the landing craft crews deserves final recognition. The coxswains who steered toward hostile beaches, the LST crews who deliberately beached their ships under fire, The maintenance personnel who kept craft operational under impossible conditions. These ordinary sailors accomplished extraordinary things. Their competence and courage enabled D-Day and the amphibious campaigns that followed. The strategic impact extended beyond tactical operations. The landing craft gave Allies capability to attack anywhere, forcing Axis forces into defensive postures that dissipated combat power, defending thousands of miles of coastline. The flexibility to choose when and where to attack, to bypass strong points and strike where defenses were weak, to sustain operations without requiring captured ports. These capabilities fundamentally changed how war was fought. For the soldiers who rowed landing craft to hostile beaches, the vessels were instruments of terror and deliverance. The approach to the beach crowded, seasick, unable to see what lay ahead, hearing bullets strike the ramp, was an ordeal everyone who experienced it remembered vividly. Yet the landing craft delivered them to the shore and gave them the chance to fight. Without those simple plywood boats and utilitarian steel ships, D-Day would have been impossible, and the war's outcome might have been different. The landing craft that delivered D-Day to the beaches were designed, built, and operated by people who understood that perfect was the enemy of good enough. They created vessels adequate to the mission, manufacturable at scale, and operable by minimally trained crews. The pragmatic excellence of the landing craft, good enough in every way that mattered, without wasting resources on sophistication that added no capability, exemplified engineering at its most effective. The ramps that dropped on Normandy's beaches on June 6, 1944, opened pathways to victory that had been closed to military forces throughout history. The simple innovation of a bow ramp, combined with shallow draft design, transformed amphibious warfare from a tactical operation into a strategic capability. The engineers who reinvented the landing craft changed not just naval warfare but the entire strategic landscape of World War II. Their achievement remains one of the war's most important though least celebrated contributions to Allied victory.